So we've looked at the design of the Q drive and we've built it. Now we need to build an apparatus to test it. So just to reiterate again, what kind of force are we generating here? We're going to generate a force that's pointed in this direction. The electron flow is back and forth into and out of the center of the cavity. These circles are the magnetic field direction into and out of the page of this diagram. The Lorentz forces, or the radiation pressure forces, are pushing up here and down here. We're creating thrust in the upwards direction. Now let's put this cavity together. We've got the bottom half of the cavity manufactured. We're going to electron beam weld the top portion of the cavity together. Now we need to build a device and an experiment to test to see whether we're creating that upwards force when we put light into this cavity. So here's the assembly of the cavity. We bring in the top piece down, connected to the bottom. We electron beam weld this, so it's now one piece. Now we need to power the cavity. How do we get energy into the cavity? This is very similar to a coax cable. We put energy in here, and we make sure the energy is at the right frequency here on this signal pickup cable. Next, we need to vacuum seal this. So we add piping to the top of the cavity to vacuum seal it, to make sure we have no air, nothing inside this cavity, so that the photon fields can be as dense as possible. Next, we need to cool it. This here is the helium dewar, the helium vessel. We fill this cavity, this dewar, with helium to chill the cavity down so that it goes superconducting, so we can get these intense fields inside of it. In addition, the entire cavity, this whole structure, is suspended off of a tube down the middle of the cavity. Then we've got to put this in a very high-tech thermos called a dewar. This is it. We've got a nitrogen jacket, then we've got a steel jacket on top of that. All this is designed to keep that cavity cold and keep a vacuum inside the cavity. Very similar conditions to what are out in space. Next, we suspend the entire cavity. The weight of that cavity is suspended off of two load cells located here and here. Those load cells are high-tech scales to measure the weight of the cavity. When we put energy into the cavity will push up and reduce the weight on those two load cells. Now what we want to do is we want to just kind of review the experimental apparatus. Cavity is here. It pushes up when we put energy into the cavity. It reduces the force on these two load cells, and we can determine whether this cavity develops thrust without use of reaction mass. Here's the assembled experiment in the experimental lab. Here's the cavity with all the equipment attached to it. And here's the circuit to measure the weight on the cavity. That signal, that's me putting load cells back into the device. We project the real-time output of those load cells onto a screen where we have a high-definition camera, so we record all that. And the results of the test are, we had over 3 test days. We had many successful test runs. Here's one sample of that. We're showing successful weight reductions in the cavity when we put power into the cavity. So we successfully demonstrate the operation of a reactionless drive. We have a series of experiments that show it works. So let's talk about applications for this technology. We mentioned it before, but let's talk again about the satellite market. The Q drive offers a way to significantly reduce the cost of launching and operating satellites. With longer on-station times, reduced launch cost weight, the Q drive can provide tens of millions of dollars of cost savings per satellite. There's another area where the Q drive provides great advantages over traditional propulsion systems, and that's in deep space destinations and destinations in our outer solar system. The Q drive can do missions in a time frame and for a cost that other systems cannot provide. With the quick travel and the reduced cost, the Q drive is an enabling technology for deep space travel. So let's summarize where we are. The Q drive is a breakthrough technology. It has a theoretical framework showing that this engine should develop thrust. It has numerical method analysis, and that numerical method analysis shows this engine develops thrust. And finally, and most convincingly, we have experimental results that show this engine works. So, a lot of people will be skeptical because of the nature of what this means. My advice to skeptics is, don't take my word for it. Go out and prove it or disprove it to yourselves. Download the model from our site. Plug that model into a numerical method program and sum Lorentz forces over the entire cavity. You will find, as I did, that that cavity operated with a pi mode wave creates a differential in radiation pressure. Cannae is the name of the company formed to develop this technology. My name is Guido Feta, and this is the Q Drive.